Hello everybody. Yeah, this is Professor Paul again, and as we have already seen the introduction to big data and data foundations, so let's look into this part of data quality and what are the challenges that we have in big data analytics as well as data science and sentiment analysis. So that's going to be the part of this lecture. Let's directly dive into this first part of data quality. Well, what is a data quality? A data quality is an essential characteristics that determines the reliability of data for making decisions. So how reliable is our data? How good is our data? For example, the raw data that we get from census or by any means might have some noise or disturbances, or in other words some ambiguity. We have considered that there are possibility that data might go missing. In the last class we have seen about 10 V's of big data, and among them there are some V's which focuses on the data quality issue, because there are data in doubt, veracity of data, right? Ambiguity of data. Yes, whatever the data that we obtain, we have to verify the data so that the data can be useful for making decisions. Is this data really reliable to make the right decisions? Can we really get some insight from these data? So there are a lot of several questions that we might come across when it comes to data quality. Let us consider few points on this data quality. If you look at this picture, you would see there are a couple of charts, and you have a calculator, pencil, a lens, and a spectacle, glasses. So as we see here, this is kind of output of some insight that we got from the data. So we don't want to get an insight, or we don't want to get the wrong insight from the data. Yes, if the data is not of good quality, eventually it's going to affect the output. Yes, it's same as garbage in, garbage out. So whatever we put in, that is going to come out. If our data is of poor quality, if our data is not reliable, then how is going to be our decisions that you are making based on those data? It's going to be the same. Yes. So we should be careful in monitoring the data as well as cleaning the data and preparing the data so that the data remains quite good enough for us to use to make certain decisions. Let's dive in and see more on this data quality issues. So there are several issues that surrounds the data quality. So here we are going to just see few points on this issue. Let's talk about the timeliness of the data. So the data are from different sources. It can be from sensors, or it can be from your CCTV, or by other means you are measuring these data. So does data arrive on time? That's one issue. Suppose you are expecting data at a regular interval, and if the data does not arrive on time, we can't make a certain decisions based on the data. We can't make assumptions either. So does it mean like we are going to make some predictions based on the missing data? We are not talking about the missing data issue here. We are talking about the integrity of the data. Is it going to be on time? Does it meet a refreshing schedule, as I told you, at a regular interval or the expected time? Does it meet the requirements for time interval for collection to processing to analysis. There are a lot of stages of big data. We will see one by one in the coming lectures. So in short, what I like to say is that when you get the raw data, and these data has to be explored first for some preliminary analysis, and then we have to do certain pre-processing. Only after that we can use these data for proper analysis, and eventually after analysis we have to take this data for some report. We have to visualize the report, or we have to communicate these reports to others, or we have to take some insight out of this data. Yes, the data goes through a long process, and does it meet the time interval from collection to processing to analysis? That's one of the important questions that we have to ask. Then comes the readability of the data. Is the content and format easy to understand? Yes, that's another issue. Most of the raw data that we have is so-called unstructured data, or in some cases semi-structured data. If it is structured data, it's quite easy for us to understand. But when it comes to an unstructured data, it's quite hard for us to clearly clarify certain things. Yes, so for us this question comes in. Can we clearly follow what is the numerics values or the images or whatever values that we get from the sensor? Does it make sense to us? Can we come to a format that could be understandable? So when I say structured and unstructured data, it's like you have all the informations or labels for certain data. If you have, then we call it as a structured data. If you don't have those informations, then it is an unstructured data. So in reality, more than 85% to 90% of all the data that we are collecting for our analysis purpose, it's unstructured. So this question of readability is a big issue. Then comes the authorization. Does using the data require certain rights or permissions, and what limitations are there? Actually, certain data that we collect, if suppose we are taking from other sources, then we have to get the right permission. And in some cases, these data are encrypted. And if that's encrypted, can we decrypt it? Or do we have rights to decrypt those data? Or in other words, what other limitations do we have? So these are some of the other issues, like authorization that we have to get to use those data is another essential part. So these days we do have many open data available for our analysis, but still there are cases in which we have to get the right permissions to use the data. Structure. Do you have the technology to transfer unstructured data into structured data? I have just mentioned the difference between the structured and unstructured data. So the question comes here, because in order to understand this data, we have to do certain the so-called processing or pre-processing. So once you do this processing, you can in fact convert an unstructured data, or in other words, transform this unstructured data into a structured data. But the question here is, do we have the technology? So unless you understand some background about this unstructured data, if you don't have a domain knowledge, you can't come up with a way to map these data, or you don't know the way to actually model these data so that it can be structured. Yes, that's a big issue as well. Then comes this credibility. What is your confidence in this data? Yeah. So this question of confidence, again, if you have the domain knowledge of the data, it would be better, it would be easy to answer this question. Again, the confidence level of the data is a big question, but it's kind of fuzzy for someone who doesn't have the domain knowledge of that data. For example, when I say domain knowledge, data are from different sources. Let us consider you have certain data of say biometric data, and suppose you are from an arts or engineering background, from maybe different engineering background, and then you are looking at these data. Say you are from civil engineering, and then you are looking at this data. Maybe you are not familiar with this data, and then you don't have any comments about these data either. You don't know how to transform these data. You don't know whether these data are reliable ones. As to making decisions, we do need those with the domain knowledge to get the credibilities of these data. So then, having the domain knowledge, of course, you can have confidence. You have the confidence to say, well, this data is quite good enough, or this data I can rely on these data. Or in other words, you can say, well, we can transform these data using some kind of mechanism. You have the confidence that we can at least use these data for some purpose. On the other hand, you might also say that these data are useless unless we do certain processing. Well, these are only some of the data quality issues that we talked about. There are still more other issues that is not covered here. Just giving you the brief introduction to this data quality. And other challenges that we have here in our data science foundation is that from data acquisition to processing, we have various stages. For example, data acquisition itself is a big challenge. Acquiring data, you have to, in fact, for example, maybe install the sensors in a certain locations. You are going to install the cameras and all other devices that would acquire data or monitor the data. If it is a wearable devices, still you have to wear those, and you have to continuously monitor and acquire the data from those devices. Okay. Data acquisition is one part. After acquiring the data, we should store it in a place so that we can retrieve these data later on and then start the processing. So before we start the processing, we may have to clean this data, because data in general, they are unstructured. As I have mentioned earlier, in most cases it's unstructured data. So we have to make sure that how much time does it take for us to transform these unstructured data into a structured one, and how much is the cost for doing so. The cost and time of processing, of acquiring the data, storing the data, retrieving, cleaning the data, and processing such unstructured data can add up to quite an investment even before we start to reap the value from this process. Yes. So which means that the big companies, that they start a group, so-called the data science group, for such analysis purpose, they have to go through this process, and they have to sit and calculate the cost before even investing on such big thing. Okay, so today the data is everywhere, and these data are used to personalized marketing. Not only that, these days the data can be used to monitor your movement from one place to another place. Monitor, say for example, you are trying to talk about, say, an issue like TB or tuberculosis, or say for example diabetes. then if you are continuously searching some issues on this, and most probably there are machine learning algorithms, they are performed on your search, and they can predict, like either you or some of your close acquaintance might have a diabetes. So eventually what they are going to do is that they are going to personalize some advertisement just for you. Yes, even many companies, they are seeing all your purchase history or whatever you have searched during the purchase history, and then they provide some recommendation that's very hard for you to resist. Yes, that's how the things are happening, say for example in Amazon or eBay and other online stores. We are going to look at some information from Amazon's recommendation engine. Say for example, like being a customer, if you want to like find a book, say on data science foundation, if you just go into this Amazon and try to say type data science, you might have various books displayed, and again these are some of the recommendations. Maybe you are looking at only one book, and then you find that there are a lot of books are being recommended. So that this recommendation engine has a pattern, and this actually features certain products that is close enough for your search. Well, you might have shopped in Amazon and you might be familiar with such recommendations. Not only Amazon, even in other online stores we have similar recommendations. Let's talk about this recommendation more. Okay, if you look at these data science books that's been displayed, you can also notice that they have their price, as well as it mentions whether they have paperback or hardcover. Moreover, they also have those stars, and just besides those stars, you also have the number of people have given this stars. Is this going to affect your decisions on purchase? Let's see what's going to happen. Yes, now we are into this sentiment analysis. Yes, company use this sentiment analysis to still or to motivate you or motivate your feelings towards a certain product. Just for example, just remember this data science book that you are about to purchase from Amazon. So for example, as you saw earlier, we had these stars, like 5 stars are there, and you can notice that some stars like 3 stars, 4 stars, 5 stars, and you have the customer's review. So here is an example where we can see like customer reviews, it's like almost 4.6 out of 5 stars, and 80% of person have given 5 star among 131 reviews. And then you have other recommendations of books with 4.8 out of 5 star, 5 out of 5 star, and so on. Yes, do you think these reviews and stars will move towards or will make you biased in some sense to move towards certain directions in making your decisions towards a particular book? Of course, many people agree that they are moved just after reading certain reviews and seeing the stars. Let's look at some reviews in short time. Yes, basically the sentiment analysis is steering your feeling to make you purchase a certain product. In other words, they actually encourage you to make judgment based on the product reviews. Your judgment can be either positive or it can be negative. Let's move further into it and see how it would affect. Okay, here again on sentiment analysis, you can see there are several reviews given here. So in the previous slide we saw the stars. We are just focusing on stars, but here again we can see it says top customer review is another field. Again, it's an extension of this sentiment analysis, in which after seeing the stars, now you want to read the actual reviews. So as you can see there, like you have 4-star, and then you have the review given below, then you have the 1-star, you have the review given below. So after reading those reviews, you really feel that, well, this book could be I can purchase and it will be useful to me. Or you might decide that, well, it's not good enough. Moreover, adding to this decisions that a customer makes individually after reading these reviews or after seeing all those stars, the reviews whatever we write, say for example you are giving a review on Amazon, and mostly these reviews are written in English. If let's consider we are talking about the English language, that is, I mean, the English website of Amazon. Yes, apart from English, even Chinese and other languages these days, they use the natural language processing. There are various analytical methods they follow in this natural language processing, along with certain machine learning methods to analyze the general opinion of a person or public for certain product. So this is why this sentiment analysis is often called as the opinion mining. Even the news channels are filled with Twitter feeds analysis every time an event of importance occurs. You might have noticed, right? Whenever there is certain event is happening, you get the hashtags, or with this Twitter informations is being fed in to you to see how much either opinion towards favoring certain things or against certain things with regards to elections, for example. Or if you have a sports game, then again you also come across certain Twitter feeds. Yes, these are all kind of opinion mining, and again it's a part of the sentiment analysis. The next part that I want to show you today is about the personalized medical treatment. We are going to talk about this human genome projects. We know that today is the human genome. We have the sequencing of this genome has been already done, and though this takes a lot of time for actual processing of the whole thing, today it is possible. We have computers, I mean not the general PC, I mean we have the supercomputers. They can perform such operations in one day. So even in one day you can actually perform the whole operation, of course if you are using the supercomputer. But in any case, we do have medical treatments that are performed today with certain specific or personalized care for a certain patients with a certain illness. Yes, say for example a patient is suffering from certain disease, and he is consulting the doctor, and now the doctor is taking the individual treatment. I mean, for example, this doctor is caring this patient, and now he recommends this genome based recommendation. When I say genome based recommendation, it's like you have this sequencing, and once the sequencing of the DNA is being digitized, these can be used or can be aligned together for certain analysis and interpretation of the patient's health. Say for example, the patient's particular gene or particular element can reflect a particular weaknesses in this person, and accordingly the doctor can give certain recommendations and he can provide certain medicines that would affect him, and it would eventually affect him in a better way. So that's a kind of a personalized treatment that's been given here, and this kind of treatment is getting popular these days. You get the sample from the patients, you take the DNA format it into a digital form, then after that you try to sequence it, you could try to align it and perform the actual analysis process, do some interpretation from these data that you got from the DNA, and then we do have certain softwares and tools that helps the doctors in a better way to perform some real-time analysis of the results that obtained, and finally the doctor can recommend him to go through a certain specific treatment that would be personalized for him alone. Yes, such kind of treatment really helps us in many ways, and today though it's still kind of a rare treatment, we are hoping that this kind of treatment would become quite common in the coming days. Let's dive into the next part, which is another area where the data science is useful. We are going to talk about this wildfire. Yes, wildfire is happening around the globe. Even recently, it happened in Russia. Right now these lectures are taken on end of March 2018. Well, still to date, like we have a lot of places around the globe, we have wildfire happening. So there are accounts that sometimes the wildfire happens in like the California or in Australia. They amount to huge loss of forest as well as the properties, in some cases even human life, as in most cases the animals they live, the wildlife are affected. To overcome some of these losses, we can perform certain analysis. For example, we have the satellite image data, and these data can give us some hint on what is happening in a certain region of the globe. Say you are focusing on these satellite data, you can identify the difference between the fire as well as the no fire region. Yes, that doesn't give a detailed information, but you do get a rough estimate that okay, fire has started in this region. And then we do have the research centers or the fire stations that are located near, say for example, that forest. Maybe not near, maybe it could be quite far, but still sometime we do have some sensors that are placed inside the forest itself. So those sensors can also give us some information. So we got the satellite information, we have this information from the sensors, and right now we can make certain decisions. Say for example, you know the exact location of the fire, and probably you might also get the heat level in that region from these sensors. But apart from that, you don't know exactly what is going on. Say for example, if you get more information from the people who are near that fire, wildfire. So these days people use social media and they communicate many messages, either text or image messages, through the social media. whenever such event happens. Say for example, a group of people are hiking near the forest and the wildfire happens, then they take a picture and they give a comment about what they saw. These will be very useful for, say for example, the fire brigade who are going to come. They know what are the equipments they have to bring. They actually know how much loss has already happened. And these days even the drones are used, and the drones sometimes they just carry some sensors and they just drop the sensors in the fire region so that we can get more specific details about what is really happening inside. As these all informations that we have gathered either from the satellites, the sensors that is placed in the forest, or the data from the social media, or other data that we gathered from the drones, these will be combinedly used for performing analysis, and you can make certain decisions that would affect people's life, that could save a lot of properties. Well, that's one of the example. In the coming lectures, one of the lectures, I will also give you some details on how this can be done. And we have this part, the rare event. Well, when we talk about rare event, whenever we say rare event, it's something that occurs very rarely, right? Yes, the key observation is that even if the data is random, then with enough data, you will still observe a large number of events. That is the objective. Though the event that happens at less frequency, this would be occurring again if you have really large number of rare events. For example, let me give this example, like consider earthquake. So how often the earthquake occurs in a year? Well, it depends upon the region you are living. Anyway, suppose you say that maybe once in a year or once in 5 years. How about the earthquake happens in 50 years? If it's once in 5 years, then in 50 years, maybe you could say like 5 to up 10 times. Well, how about in 100 years? How about in 1000 years? So as the number of years increases, the rare event that occurs also increases. Yes, we are talking about this hypothetical event that have the potential significant impact, because rare events are the ones they are going to have a significant impact. We are talking about tsunamis, we are talking about earthquake. Yes, they are rare events, but they can have a significant effect. So to understand this, let's look at this part here. Say for example, you have a coin and you toss the coin 10 times and consider that you want this coin to turn 10 heads. What is the chance? Yes, the chances are very less, right? You are tossing a coin 10 times and you want the coin to turn 10 times head. The probability is very less. So however, if you perform this experiment lots of time, then the probability that the event would occur would eventually increase. So that's what shown here, as you could say, considering this coin toss. So for example, if you repeat the experiment 10,000 times, then the expected number of times you see 10 heads is like 10,000 over 1024, which is approximately 10. If you repeat this experiment a billion times, you would expect to see 10 heads approximately 1 million times. So this phenomena occurs in big data, because we are talking about huge amount of data, which means that the rare event that's supposed to happen is also quite high, as we have huge amount of data. So let's consider this example of face recognition. So for example, you are looking at a criminal. You are looking at a criminal face, suppose, and then you want to identify the difference between a criminal and a normal citizen. Say for example, you have this face recognition system in the airport, and these passengers, they are passing by these cameras or automatically detecting whether they are a criminal or not. Well, suppose if this face recognition system has an error of 0.01%, even if it has a error of 0.01%, so there are chances that a normal citizen to be identified as a criminal. We do have chances, as we have millions of people passing by this camera. A normal citizen might be falsely recognized as a criminal. Yes, there are chances, right? And as you have many people being recognized as criminal who are not actually a criminal, in fact they are all passing through this face recognition system. It doesn't happen like in 10 people or 100 people. When we talk about millions of people, yes, in millions of people we have hundreds of false recognition might happen. At the same time, when you have millions of people pass by, there are chances that the actual criminal would also come in, and he might be turned as a false criminal. We have like the actual citizens who are passing by the camera, and you come to know that they have been falsely identified as criminal. And since you already have many people identified falsely, and when now you have the right criminal comes in, and now you are wondering whether he is really a criminal or the camera is detecting falsely. Well, that's another question that we have to think about when it comes to this rare event. So, well, today we have saw some instructions about data quality, sentiment analysis, as well as some of the information on wildfire and these rare events. So that's all we have for today, and I hope to see you next time. Have a nice time. Let's meet again in the next lecture. Goodbye.